let's yield to Mr. Bannister to give his update.
Well, yeah, like as you saw the Slack channel, yeah, I finally got my private scores and the public scores to be over 0.9. Both of them were just sort of fractionally over the line. Yeah, so that was based on the kernels I was talking about last week, which is using Catalyst, and it uses 3 classifiers and 3 segmenters, and then ensembles on those. So it uses the classifiers to sort of divide the data into basically sort of images with defects and images without defects, and then just does the segmentation on the ones without any defects. It also uses, rather than just like having sort of one single threshold value for each defect classification, it does have like different threshold levels for each defect. Yeah, so within that, the segmenters it uses like a standard UNet as one of them, and then it uses the pyramid one and another one, a PSP one. So I haven't actually looked into what those alternative segment models are, but yeah, so I just used them. Basically, I was just trying to recreate the guy's results, and then I was going to work backwards from there.
Yeah, no, that's great. You did that, Steve, because I think just commenting, I think Rickle and I were exchanging in Slack messages. At least my understanding, and Rickle can chime in if he's had a look, is FPN seems to be identical to basic UNet. Don't know, Rickle, whether you've had a chance to look at it, but at least my interpretation is Jeremy was right. It's just exactly the same. It's just that the picture is drawn inverted. So instead of a U, you get like a inverted A. Any comments, Rickle?
Oh, he's writing in the comments. He says, yes, it is identical. He says he's traveling.
Okay, I see. Okay, sorry, I didn't see that. Yeah. Yeah, so I think that was, but PSP.NET on the other hand is definitely, I think right now, and I checked on this papers with code for segmentation, and I'll talk a little bit about that. I haven't had a chance, but there are at least 3 papers, and of the 3 to pursue, I would definitely put PSP.NET high up there as well. There are 2 others that I'll talk about when it's my turn. But yes, so I think definitely UNet is one. FPN is same as UNet, but in implementation, it might still give you a little bit of a difference depending on which layers you connect and stuff. So and then PSP.NET, as a group, I think that's one. Maybe you can look at it, Stephen. We can get a update from you of how that works, but it's definitely one that's worth understanding because it seems to be in the top 3 segmentation scoring networks recently.
Yeah. If I can just if I can try and share my screen here, I can show you some of the results from each of the classifiers and from the segmenters. I'll just share my screen, although
that'd be great.
Every time I try to share my screen, things tend to go slow. I'll try and see.
Yeah, and while you bring that up, I think the other 2, since we have a few minutes, and Rekil is saying that, so I think that would be good. He is looking at DeepLab v3. And Rekil, if you can hear, then I would even suggest that you look at DeepLab v3 Plus, which is, I think, released in 2018 and is somehow, obviously, Plus means some improvement. So it's some kind of an improvement on DeepLab v3. So that's apparently the second best scoring segmentation network that's used. And then just 2 days back, I think, I found something which currently it seems to be getting the best score, and the paper was just released in March of 2020. So anyway, I'll keep quiet now. Steve, take over, and we'll talk about it later again.
Okay. Can you see my screen there? Okay.
Yes.
Yep. Yeah, so as I say, there's three classification models, which is these three, and then there's the three segmentation models. So my final score was based on all of these six together. But yeah, the interesting thing I found was, yeah, so like this is just starting. The first classification model was just like a basic ResNet 50. He splits it into, yeah, I think it's 5 folds he splits into. But he also trains his classification on, he has like, it's set up to do the 5 classes, so the 4 defects and the no defect. I'm not exactly sure why he did that, when basically what he wants to do is just use the classifier to get rid of the ones without any defects. I thought he could have just done a sort of binary classification, but I'll look into that further. But you can see here, so on the validation scores, pretty much they're all round about the same value of like 0.98. There's not a big difference between the three. But if you look at the actual, like the training times, so you can see like this last one here, this is per epoch. So he's doing training for 40 epochs, so it's like 40 epochs times nearly 20 minutes. So this one here took an awful long time. And yeah, so that's on an SResNet. I'm not exactly sure what a SE
Quick
ResNet
question,
is.
Steve, I think Rekil is asking on the chat is, did he use different thresholds for the class? You mentioned that's what he did in the segmentation portion, correct?
Well, he's using different thresholds. Once he's created the segmentation images, then he uses the thresholds to decide if he's going to keep the image or not, and the segmentation image to like dump it out. I'm not sure if there's any thresholding on the classification, because of the fact he's using this catalyst model. So like each catalyst model has like a YML file describing what it's doing. So you can see here, this is for the ResNet 50. This is its setup file. So yeah, you got like the 5 folds and the 5 classes and the ResNet 50. He does down here. There's like there's this threshold, but I'm not exactly sure what this threshold applies to.
0.5. But is that 0.5 in? Well, that doesn't seem to be per class or anything. And also interesting, he uses the random optimizer, which
yeah.
The question Rekil is asking, that the same question I had is it 0.5 for each of the classes?
I'm not sure. I would need to look into that more. I don't know, but yeah, I don't know, but
okay, that would be something to
look
at.
Yeah, so as I say, like each of the classifiers gives it approximately the same score, but yeah, like a massively different time taken to use them or whatever. So I'm not sure how much advantage there is, because he applies these across, like he uses folds 0, 1, and 2. He actually misses out on 2 of the folds. So I'm not sure would you get like an equally good score if you just applied the first one to the other folds.
Yeah, then, and also, is he by any chance picking the fold that, or I assume he's picking the fold that gives him the best result? Is that correct?
Well, I think he's just, I think initially what he's like started off doing was like he was going to sort of apply a classifier to each fold and then combine them. I think he just probably ran out of time or whatever, because each one of these takes like a day to run or whatever. So I think it's just he never got around to doing folds 3 and 4.
One fold from each. That's all you're saying, because in fact it's very similar to what the guy, even the earlier kernel we were using, right? Initially he started off thinking he'd be using 3, 5, and then just gave up and just used one fold. So
yeah, he was exactly the same. Yeah, he just did one fold because he ran out of time as well. So yeah, and like over here in the segmentation data, again it's the same, but like here he's just using fold 0 for all the segmentation stuff, which yeah, for me, yeah, so that means like, yeah, because he's split into 5 folds, 20% of his data he's reserved for the validation set, but he never actually sort of trains on it, which probably puts his scores down a bit. But like anyway, again here it's like the same type of thing with yeah, like the scores he's getting. Obviously the best score is this one here from his like is the pyramid network or whatever you call it. But you can see again, once again here, this is taking like 10 minutes per epoch to train, as opposed to the PSP one, which is 4 minutes to train.
Wow.
So, and like,
Actually,
yeah, and these scores here, each of these is trained for 40 epochs, but like each was like still improving. So if this one here, the PSP net, if he'd run it for like the same amount of time as the FPN one, then perhaps it would have had an even better score. So yeah, again, it's something to look into, because it seems to be like the pyramid one takes substantially longer than the others.
yeah,
Yeah.
also it's interesting that um, the accuracy numbers that with rest, just sticking with UNet, for example, because it's, I'm assuming, a somewhat similar apples to apples comparison, even though it's simplified here because of the fact that he has done classification already, right? So he's just doing the
Well,
segmentation of the ones which have the
oh,
defects.
in this case, it's not. Sorry, each of these scores here, these are these models by themselves. There's no classification at this point.
Oh,
So this was just the UNet purely doing segmenting. It's only once he has like each of the segmenters trained and each of the classifiers trained, then it's just like in his final like ensemble he applies the classification. So here the segmentation is on all of the images.
I see.
The
Okay, and is it done
classification
at
hasn't
full
been applied
size?
yet.
Is it done at full
Sorry.
size?
Yes, it is. Yes. Yep. Yeah. So that's that one.
Because the thing that I
Yeah.
find
So there,
surprising, sorry, go ahead.
yeah, this here's the setup file for the PSP network. So you can see here exactly, he has like this minimum size thing. And like this is the transforms he's doing. So he's using cutout transform as well, where you're getting like the little black holes. I've noticed here he's doing like this loss, the BCE dice loss,
Nice. Ah,
which sounds very similar to what you've been trying yourself over the last few weeks.
yeah, that's
I haven't
interesting.
looked at I haven't looked at his loss function, but yeah, it looks as if it's a combination of the two as you've been trying.
Yeah, yeah. I got the BC. Well, no, unfortunately, well, we'll get to it. But I'm still encountering problem with BC despite Rakil's help. That's a separate subject. But yes, it would be fascinating to see what he does with that loss. But also, yeah, the focal gamma. So he might be doing something like more than just standard BCE, I suspect.
Yeah, again, all of the I think the loss functions that he's using are sort of standard in Catalyst,
Hmm.
but again, I'd look into that.
Oh, yeah, that'd
Yes, I'm not
be
sure.
interesting then to look at. So
Yeah,
cutout augmentation, and then this looking at BC dice loss, which is interesting. I just named mine that I didn't know there was one that existed.
yeah. I'm not sure. Has he taken two of theirs and combined them somehow? I need to look at the code again, but
Yeah.
yes, the code is all in his stuff.
Rekil in the comments said the learning rate is very low, 1 e to the power minus 5. Yeah, that seems quite low to me too.
Yeah, the encoder LR. But the encoder he's using is interestingly ResNet 18.
Yeah, that was on the PSP. Yeah, so the learning rates and stuff, you can see like here. So the learning rate is adaptive. So he's starting at 0, 0, 1, but yeah, by the end it's dropped by a power of 10. So I'm not sure exactly. Yeah, so I don't know exactly where those get applied and how they relate to like to these learning rates here.
Interesting though. Yeah, I was going to remark that back when you shared the overall summary tables, the interesting thing to me seemed to be that, even your runs and my runs with just the dynamic unit seem to give the dice scores more in the 0.86, 85 kind of range with very less training, even like 2-3 epochs with the fast AI stuff that we used to do. This one
Yeah.
seems much lower, but I don't know, because of the ensembling, I assume it gets to such good results.
Yeah, again, like I'm not sure here is that, yeah, I presume this is just like a dice metric. I haven't looked at like his dice metric function to see if it matches up with the one that was used when I was using the fast AI code. But certainly, like as you say, when I was running the kernel with the fast AI dice metric, I was actually getting like sort of training losses or sort of training dice scores of 0.92 or whatever. I was getting really good
Yeah,
values. Although
exactly.
that didn't translate into when I actually submitted into the Kaggle competition.
Right, right.
So
But still, it was in the high 80s for sure.
yeah, yeah. So what I wanted to do actually was here I've only submitted from his ensemble or whatever. So if I look here, here's where it started. Yeah, so here this score here, this here is like with one segmenter and one classifier. So like again, like it is like an ensemble with the two, and yeah, like so that was just slightly below. And whereas like there's the last one, that's the 3 classifiers and the 3 segmenters. What I wanted to do, what I was going to do next was, yeah, so back here I was just going to take the UNet by itself without a classifier and yeah, submit that into Kaggle and see exactly what dice score it gives me then to see does it match up with sort of what the training scores are giving me.
Yeah.
Just to,
Also, regular the comment, which is, the regular unit, and I assume that's what he's using, not the dynamic unit. And so he says the dynamic unit has a lot many more parameters. That might be a reason for the score difference between what we are seeing and what we saw when we use FastAI, which uses dynamic units. So that could be a reason for it. But I had a quick question. You said you used one classifier and one segmenter in that score that you shared. Which classifier and which segmenter?
it was just the first one of each, so it would be yeah. So these numbers here are the numbers of the order they were done in. Yeah, so the first classifier was the ResNet 50, and the first segmenter was just the standard UNet with a ResNet 18.
So that score alone is, if you can go back to the scoring, is pretty
Yeah, so it's that one.
high, right? It's almost as good as my best score with which I would expect with the dynamic unit, because you have a 2-state classifier and then a segmenter. But so that seems to say just the unit gets you very, very close. The only difference, so I'm seeing the difference is dynamic unit versus unit, and then also you're training on the full image size. So if we didn't chunk and we just did dynamic unit and trained on the full size, that's something I might want to try to see how high that gets.
Yeah, and also as well, it does have the per defect thresholding on it as well, which we didn't have before.
Oh yeah, that's right. Yeah.
Although his is basic, it is like just sort of, I can't remember the exact numbers, but it's like something like 500, 500, 1,000, 1,000, something. Yeah, so it is just sort of fixed numbers, one for each defect. So yeah, you could maybe apply those as well and see how it affects the dynamic unit.
Yeah, that's right. That would be an interesting experiment to try. Okay, thanks.
Yeah. So that's about it. But yeah, I just have like a lot of other stuff to look into from all of that.
Woohoo.
And yes,
First person though to break the 0.90 barrier. That's pretty good.
it did though. Like, but then I actually like looked at the proper leaderboard or whatever.
Oh yeah, that's depressing.
Yeah, like it doesn't even get you to the silver medal places. So
But
there's a
it
way to
does
go
get
yet.
you in the top 10%, I think, right? No?
I think so. Yeah. No, it's
Because
like
I think it's like 0.90 gets you in the top. There were like some 2,100, 2,400 something competitive.
Yeah, on the private leaderboard, it got me to position 123.
Yeah,
Out of
that's definitely
2,381. So yeah, like it's actually 2 places outside of silver medal. So nearly there.
But that's excellent though. That and that's where, though it kind of, I mean, it's yeah, like you said, it feels good when you can work to get it past some marker like that. Now, the only thing which bugs me is the fact that ultimately it's still a ensemble, and like computing. I still would like to see this is where Jeremy and what Raquel have been trying makes a lot of sense. Is like how much can all these techniques push you to get to with one kind of approach, and then but it's remarkable that you were able to ensemble just 3 of them and get it that high, because you see a lot of the teams doing like 7 and 10 and stuff like that. But even that's why to me what's even remarkable is your single classifier, single segmenter is almost there.
Yeah, I think just having the classifier with one segmenter gives you like a massive boost in your score. Just because of the fact there are like so many images without any defects on them. Just doing the segmentation on ones with defects really helps a lot. So
yeah, and I think this full size thing, because I've seen it remarked elsewhere, that the full size and kind of pointing in that direction, this progressive resizing and full size seems to provide a lot of benefit, is the comment that I've seen repeated. So that's something else, instead of sticking with 256 by 256, which is what we were doing with the other kernel, if we can progressively resize or even just go train it on the full size, then that would be another, I think it ought to give a boost because of
yeah,
that.
because I think the trouble with the sort of 256 tiled images is if the defect is like split across tiles, you sort of like lose that information. Whereas yeah, like by having like the images together, it sort of it keeps the defect segment area together.
Yeah. Yeah.
Yep.
Great. This is really good, excellent detail to dig into, especially since you posted the link to the notebook and stuff. It would be awesome to go through and figure out what all is happening. And another, I guess, framework that I'd like to dig into to see what kind of losses and how they're used. So is this all in PyTorch or?
Yeah, so like as I said last week, Catalyst sits on top of PyTorch,
Okay,
so it would
good.
be the same as sort of Keras on top of TensorFlow or whatever, or even FastAI on top of PyTorch. So
Right.
it's very similar to sort of FastAI, but less orientated towards notebooks and more orientated towards just command line running. But there's like there's a lot in there. Plus as well, it uses that segmentation library that we've seen before. So it's pulling all its models out of the segmentation library.
So it doesn't. So it pulls it from some of the libraries we have seen, or does it have its own set?
No, I think it's pulling them all out of whatever it's called, Segmenter. I can't remember the name of the.
Yeah, there
library.
was one that Mehul had shared as well multiple times, and that is quite popular for usage.
Yeah, exactly. Yeah, so like in the notebooks that are shared in my GitHub thing, sort of in about the second cell or whatever, it pulls 4 things in. It pulls the Catalyst library in, and then it pulls the segmentation library in. It pulls that augmentation library in, and it pulls some TTA library in. So it uses those 4 components.
I see. Fascinating. Great. So that's awesome that you're able to break the 0.90 barrier in just across. But I think, as you said, I mean, there may be, you just kind of started, so there may be many games you can still play with things.
Oh yeah, definitely. Yeah.
Yeah, that'd be great. Okay. Don't know whether Rekul, given he's traveling, may be able to talk. Anybody else? Mehul, Alvaro, I think Carlos. Anybody else want any to provide any updates, comments? Okay, if not, then what I'd like to do is my week was pretty unproductive on this front. I think I ended up just chasing a couple of topics, neither of which I was dug down to the bottom of, but I'll try and share my screen and talk through couple three, which again, anybody may hold yourself. I know Rekal was interested and is probably going to pursue a couple of them, and I'll try and dig into them as well. So let me share my screen and we'll talk through the 2 or 3 ideas that I was chasing down for implementation. Can you all see my screen now?
Yep.
Okay, so the first one that I was chasing down was yet another loss that I thought I could implement, and it actually is referred to in the Sevastyle document that I have as the bi-tempered logistic loss, and apparently it helps you deal with noisy labels. So I was trying to get it implemented. I haven't succeeded. There is a PyTorch implementation hanging around, but I needed to customize it and get it working with this data, which I'm in the process of doing. So if anybody else is interested in taking a crack at it, please do so, and we can exchange messages on how far or how much progress you've been able to make. But just quickly to go through it, it seems it's interesting. I do not, there is a paper associated with it, but I'll just kind of take it to the blog very quickly. I do not, to be blunt, understand all the math, but I do understand enough to implement the code, since it's available for Keras, and also I think I found some PyTorch implementation. But bottom line, what it seems to say is that if you look at the logistic loss, especially if you have examples that are outliers, then the logistic loss function they show mathematically in the paper is sensitive to outliers. And that is because, and this is where the math gets beyond me, is the loss function grows without bound as the outliers are far away from the decision boundary. But the bottom line, the effect of it is, as you can see from these 2 animated pictures, it seems that what the network tends to do is grow the bounds, or at least expand the decision boundary in order to comprehend or take into account or learn from the noisy labels. And the other thing is the mislabeled examples nearby, which is the counter of being far away. So that's the one on the right that also tends to, in one case, it dominates the loss, and in the other case, it tends to stretch the decision boundary. And these 2 effects are countered in the paper by what they provide as 2 parameters. And that's why the bi-tempered name comes in, which is, a temperature 1, T1, which again, I might get this stood up, but you can read the paper. T1 is typically between 0 and 1. And right now I'm just trying with a fixed value of 0.2, let's say, or 0.8 or something like that. And that helps in one of these situations. And that's I think the large margin noise, if I'm not mistaken. I will learn more about that as we look further in the blog. And the other one the other temperature T2, which is typically greater than 1, is something that helps the loss function behave better, and therefore the results become more generalizable by working on the tail of the transfer function. So if we look at this way at the bottom here, are you folks able to look at the logistic loss by tempered loss diagrams?
Yep.
And so that shows what happens with just this. The top row is just the logistic loss with a very clean data set where you can see that there's no intermingling of the blue and the red dots, as compared to the small margin noise, where you can see a few blue dots right at the edge of the red and a few red dots right at the edge of the blue. And that's small margin noise, and that is helped by using the heavy tailed portion, which is more modulated by the T2, that is the T2 value. And as opposed to, and you can see that the classifier for logistic noise, it kind of tries to stretch and has that white boundary around it. Whereas you can see in the bi-tempered logistic loss when that's used, so it's the one that I'm pointing at right now, the one at the second row, second column, and that's a much better behaved classifier than the one on top. And then you move, and that's done by using a T2 value of 4. And then you go to the next column, there you see what they label large margin noise. That's noise right at the center of the blue. There's a bunch of red dots, and then way outside, like outliers or whatever, there are a bunch of blue dots in this red segment, or where it's predominantly red dots. And again, there you can see, because of these blue losses, in case of logistic loss, the boundary seems to stretch out. Whereas if you look at the bi-tempered logistic loss, that effect is minimal and it's still well behaved in the classification. And they show that when you have random noise, so you can see a lot of blue dots, a lot of red dots within the blue and then a lot of blue dots within the red, you can see that with logistic loss, it tries to really stretch to comprehend the boundary. And as compared to the bottom row, fourth column, when you use both the bounded and heavy-tailed approach, which means you use bi-tempered, which means T1 is 0.2 and T2 is 4 in this example, you get really well-behaved compared to the top logistic loss alone. So that's in effect the effect of using T1 and T2 and changing the and thereby modifying the loss equations. And they also, I think, in the paper talk about, instead of logistic loss, which is based on the Krugler's KL divergence, this one is based, I believe, on a different divergence, and that helps explain the math behind it. And you can look at the full paper. There's a link to the full paper here. And there's also stuff you can play around with and see what happens as you increase the noise and change the noise level and change the temperature values, and you can see what effect it has, which is pretty cool.
Rekel was asking there, T1 and T2, the hyperparameters, do you know how you go about choosing those?
Other than knowing that T1 is less than 1 and T2 is greater than 1, I don't know. I glanced at the paper, but off the top of my head, the simple answer would be no, other than that range, meaning, T1 is obviously between 0 and 1 and T2 is above 1, but I would need to read the paper. Right now, I'm just trying to get it fixed at some value like the focal loss and see what it does. And then I'll begin to play with it and see whether they give any specific suggestions in the paper on how to modify it or on what basis to choose what value. Short answer is no.
Okay.
But that's kind of one of the things that I was trying. I got it at least on PyTorch. I haven't yet gotten it to work in PyTorch and integrated with this particular problem to see it run successfully. So that's an effort, because it seemed like a generically applicable approach as well that could be used to improve the basic logistic laws. And in fact, it'd be interesting, Steve, if I can get this to work, to even use this loss in the classifier that you're using and see whether that improves things.
Yeah, that'd be good.
So, but anyway, let's see whether I can get it to work. So you welcome anybody else on the call to try this as well. I thought it was interesting because it seems simple enough, but from what they show, it seems to have an impact. And even on a basic logistic loss, it would be a good loss to have coded and have handy to use in other classification instances as well. And as I said,
Yep.
I haven't yet dug into the math and to the reasoning behind why, if you go back, the math behind kind of the temperatures and what they do to the curve of the loss and the transfer function and how that helps. It's somewhat like focal loss, as you can see. It seems to be doing something to the curves when the noise interferes with the algorithm's ability to get a good classification going and prevent it from stretching incorrectly, if you will. So that's one effort that I made some progress on, but didn't accomplish much. Hopefully next week it's different. I intend to keep moving forward with that and see whether I can get it working. And this is the paper on which, and the name of the divergence that I forgot is the Bregman divergence versus the KL divergence, which is what, Kullback-Libler divergence, which is what the standard cross entropy uses between labels and predicted probabilities. Okay, moving on, the next couple of things that I started to look into and exchange emails, just like Steve mentioned, PSP.NET seems to be a better network to use for segmentation problems, or like the ones we're dealing with here, and compared to the UNet. The two others that I saw, and I'll switch here and see whether I can bring them up, is this is the DeepNet. Can you see my screen PDF?
Yep.
Okay, let me increase the resolution a little bit. Okay, so this is the, and this Rekel said, don't shame me on how many PDF tabs I have open as well. But this is the Deep V3 paper on what, and I just downloaded it last night, but I haven't had the chance to look at it yet. But there's a Deep V3 paper, and this one is the Deep V3 Plus paper, Deep Lab V3, or I believe it's called, from Google. And these seem to provide the best instant segmentation results currently, although the seem to be very large networks from what I recall. But they also use this spacious pyramid pooling, but I don't know what the ATRIS term means. So there's quite a bit of
I was going to
reading.
ask you that. I was going to ask you what. Yeah, I don't even know how to say that.
Yeah.
Atlas separable convolution.
Yeah. Is it ATRIS or ATRIS, or I have no idea. But actually,
Right.
the word apparently means something specific in English. So I looked for ATRIS and it has a specific dictionary meaning. So I don't know whether that meaning translates here. I would assume it does, but I have to look into that.
Okay.
So DeepLab v3 gets, it seems, until recently was the best, the DeepLab versions, and they had the original DeepLab, then v2, then v3, and now v3 plus. So that's something to chase down of what it means, and apparently Rekil was already looking at it because it gives good results for his work purposes as well, or I should say he was looking at it for work as well. So he may be able to look at it. I'm interested in it. So we'll see whether we can provide an update of how much of it we understand. And there is, being Google, there are, I believe, paper and code implementations available as well. So that'd be interesting. In that process, I found this paper, which, as you can see, is March 2020. And this paper is, or a set of papers, there's a couple, three. This one seems to get the best instance segmentation scores currently. So it's at the top of papers with code for segmentation problems. And it's called HRNet. And I just, the thing that was interesting to me about this paper is it said it used less parameters than PSPNet. I don't know its parameter count with respect to DeepLab v3 or v3 plus, but it seems to do more with less parameters, which is definitely something that interests me. And Rekil was interested in looking at this as well, since it potentially could also help him at work. But and it's this paper is just really, really interesting also because it has like a tremendous reference list. If you can see, there's like 100 and 195 references.
I've never seen so many people write a paper before as well.
Yeah,
There's about 20 people
true.
written it.
Yeah, you know, but it's kind of, but what is fascinating to me is it's not that hard to understand what they're doing. If you look at the, you know, and again, I've read about 3-4 pages of it, not more than that, but you know, it's kind of interesting if you look at it, and I'll explain if you ask too many questions. I think I'll just, my standard response would be, I haven't gone through all of it, but still, you know, if you just stare at this paper, it's kind of interesting. They just take the image much like you would in a, you know, in a unit or whatever, except that they keep this resolution. And then, you know, they use a strided convolution to get to a lower resolution image, which is this, I don't know, orangish, whatever, trapezoid or, you know, three-dimensional form. And then to illustrate the image thing. Then they go on for a while, and then they again do the same thing, and then they go on for a while, and then they again do the same thing, and then they combine all these 4 resolutions. So in a way, you can see that it kind of does the parallelization of, you know, of a unit-like thing, but they do this strided convolution to reduce the resolution at fixed points and then take it forward in parallel. And then what they do at the end to combine it is where I have not yet gone through, but they do certain things to combine these 4 images at different resolutions to get back their stuff. And, you know, they also use some form of this pyramid pooling. So pyramid pooling is, I guess, something that we could all benefit by getting a better understanding of. It seems like it's very foundational to PSP.NET, because that, in fact, PSP, the P stands for pyramid, and deep lab, as well as this HRNet. So I think it'll be good if all of us get a much better understanding of what that is and how that works and how it helps. So this is how much progress I made in going through this paper. I still have to read through a lot of the rest of the stuff, but it just seems very interesting and seemed to be efficiently getting a much better score, which, given what we repeatedly see, that we just need more and more compute or more ensembling or something, I thought that this would be a good paper to read and see how that happens. And in fact, even here, they've already started having multiple versions. They talk about HRNet v2 in this paper, and HRNet v1 is the prior first rev of their paper, I believe. And HRNet v2 already gives them much better results than HRNet v1. And the good thing about this paper also is the fact that they have the code on GitHub.
All right, I was going to ask you that. Yeah, was it available?
Yeah, it is. Yes, it is. Right.
So I looked up this truth convolution, and it turns out that truth means with holes. It's a French for with holes, and what it is basically a convolution filter with holes in it. So you can imagine a 5x5 filter where you only keep every second pixel, and then what you end up with is you're seeing the same field of view with a 5x5. You're seeing the field of view with a 5x5 filter, but you're only sampling it at 3 points. If you let me share my screen, I can show you a post that has a good example.
Yeah, that'd be great. I stopped sharing yours.
Okay, so here we go. Let's see now. I want to this one. Let's see. Are you seeing what I think I'm seeing?
Yes.
Okay. So now I've lost sight of it on my screen. Oh, there it is. Okay. Yeah. So here's the sort of the video of what it looks like, and it's a very simple idea, but it's basically you get
Joseph,
the.
you have your.
Oh, it's in front.
Something's
in front. Oh, okay. Is this better now?
Yes.
Okay. So you can see this video, and tells you exactly what the truth filter does. So you have this 5x5 convolution, but you're only keeping every second pixel, which is the 9 darkened pixels. So it's a way of getting the 5x5 receptive field, but with a lot less overhead. In other words, instead of processing 25 pixels, you only have to process 9.
So this seems like another way of upsampling, which is what you do with you do it differently in UNet or dynamic UNet, and in this case, you just upsample differently. It seems.
Mm-hmm.
Okay.
And it said, so this is I'll just show you this post. It's this thing on Medium. So, and just scanning it really quickly, it says that it's been found useful in segmentation problems. So.
Oh, okay. Rekil says it's a replacement for downsampling. Okay, yeah, I guess it's just that you sample. Yeah, it's not upsampling, it's downsampling. Okay, different way of downsampling.
Yeah.
Interesting. Yeah, I knew that etrus actually meant something, which is why they called it that. But so you're saying etrus in French means holes?
With holes, yeah.
Oh, okay, with holes. Okay.
Yeah, so it's very
apt.
Yeah.
Descriptive, if you understand what it means.
Yeah.
Interesting. Fascinating. So I think that and Rekil also says it's very performant. So that's really good. So this HRNet, the Deep Lab v3, and the PSP.NET, if we can divide and conquer different pieces, and also I'll still try. I still mean to keep at getting the bi-tempered loss working as well. So if we can get that working and even get a understanding of these different networks and what they do and how they do it, to where we can discuss the paper and the code over the next couple of sessions, that would, I think, be very useful to allow us to kind of implement these networks and use them on this problem and understand how they work as well. So I think that's would be excellent if we can make progress on these fronts.
Srinivas, would you mind posting some of the papers that you showed?
Oh yeah, I'll
reference papers. Yeah,
yeah.
Then I could look up. If you want to divide and conquer, I can pick one of them and look at it.
Yeah, I think any of these three, PSPNet, HRNet, or DeepLab V3, just let others know on Slack which one you're looking at, and be interesting to look at different all three and gain a much better understanding of what they are doing and how they are doing it, and the techniques and the code. If we can get to it, we can do it piece by piece, but it would be interesting. Maybe get a conceptual understanding and then go to the code and go through the implementation and stuff.
Sure.
Yeah, and I think Rachel says we can, maybe we should all look at just one paper, because they are not easy. That I agree. Each of them takes you through multiple techniques and stuff. So we can do that as well. Is just focus on one. In which case, then I think the right one to focus on is probably the PSP one, because that's foundational. It seems the pyramid network is foundational. We also have code. We have working code from what Steve provided. So maybe the PSPNet, and I'll post a link to the PSPNet paper once we are done with the session on Slack. So maybe we can all jump on it, and Steve has already had the code implemented, so he can just focus on the thing while the rest of us look at it, as well as look at his code to see how it's implemented in Catalyst.
Yeah, one thing about my code was, the guy, he'd written his code using the previous version of Catalyst, or like an older version of Catalyst. So I had to make quite a few changes just to get it to work with the latest version. Hopefully I've checked all of those into the GitHub, but there's a chance I might have missed some of the check-ins or whatever. So if you do try it and run into any problems, just let me know and I'll make sure I've updated everything.
Yeah, that'd be good. Yeah, so I think let's all jump on PSPNet and get that pyramid pooling concept under our belt next week. That'd be kind of cool, because that seems foundational to all three papers anyway. So, and if anybody else cares to implement that loss, bitemporal loss, or dive into that paper to get some understanding of what the math behind it and explain it, that would be welcome to Joseph. That's another area to look at, because that seems to me to be applicable beyond segmentation as well to a lot of classification problems.
Okay, so you'll post that reference as well?
Yes.
Okay, great.
Yeah. Okay. Anything else that anybody wants to cover, address? Mehul, I think, needed to drop off. Anything else from anyone? We have a lot of reading and poking around to do next this coming week as well. So that'd be good. Keep us busy. All right. Congratulations again to Roger Bannister. And
Thanks very much.
you can kind of maybe squeeze a few more, get further below the 4-minute mark by next week.
Yeah.